We speak student!
Multiplying matrices, a la Shmoop. Jerry is a terrible lawn bowler and wasn't able to make the team. However, everyone who did make the team felt a little sorry for him. So they decided the least they could do was make him their errand boy. The men and women's teams have just turned in their equipment list for the season. The coach tells Jerry that it costs $10 per ball, $2 per pin, and $20 per uniform. What is the total cost of equipment for each team? Well, we know that to find the total cost for each team, we'll need to multiply the number of equipment units by the cost. Remember that if we're going to perform operations with our data, we should put our data in matrix format, with equipment numbers in one matrix and costs in another matrix. But before we can multiply two matrices, we need to make sure that the number of columns in matrix A is the same as the number of rows in matrix B. In this case, we have 3 columns in the first matrix and 3 rows in the second one. Checks out. To multiply the two matrices, we'll be doing something funky. We'll multiply corresponding entries in the first row of matrix A and the first column of B, and then add. So, the first entry in the matrix is 5 times 10 plus 20 times 2 plus 15 times 20. And the second entry is 6 times 10 plus 15 times 2 plus 14 times 20. 5 times 10 is 50, 20 times 2 is 40, and 15 times 20 is 300. So 50 plus 40 plus 300 is 390, which gives the men's team total cost of $390 for their equipment. For the women's team, 6 times 10 is 60, 15 times 2 is 30, and 14 times 20 is 280. 60 plus 30 plus 280 is 370, so the women's team total cost of equipment is $370. Notice that our ending matrix has dimensions of 2 by 1, which is also the row of matrix A and column of matrix B. If he keeps up the good work, Jerry may soon be promoted to errand man.